right, let's go over the mini quiz on solving systems of equations by graphing. And our learning target is that we will be able to solve a linear system of equations by graphing. Graph each equation below to find the solution of each system of equations. Approximate when necessary. Remember to list the solution as an ordered pair. So number one, these two lines are already in slope-intercept form for us, so that makes it a little bit easier for us to graph. Number one, y equals 2x minus 4. So we see we have a y-intercept at negative 4 and a slope of positive 2. So let's go ahead and plot our y-intercept at negative 4, slope of positive 2. And we'll go down 2, left 1 a few times. So we'll graph our first line, and remember, we don't know where the two lines will intersect, so we want to make sure we're extending our line all the way to the edges of the graph. It's just good practice. And then y equals negative 2/5 x plus 8. Our y-intercept is 8. This slope is negative, we see, and it's 2/5. So down 2, right 5. And I see my solution already right there. Down 2, right 5. Up 2, left 5. Second line. And we see our point of intersection right here is at 5, 6. 5 up 6. And if we were taking a test or quiz and we wanted to make sure that we have the equation correct, we will solve or do a check step by substituting. So let's go ahead and do that because that's good mathematical practice. Y equals 2x minus 4. Instead of y equals, we're going to sub in 6 equals. Instead of 2 times x, we're going to sub in 5. So 2 times 5 minus 4. 2 times 5 is 10. 10 minus 4 is 6. And that checks out. And it's not enough to just have the solution, the point be a solution of one equation, because remember, this line has infinitely many points. We are specifically interested in see if that is the correct point. So it has to work in this line and it has to work in this line because that's the single point of intersection. So let's do the check step for the next line as well. Instead of y equals negative 2/5 x plus 8, we'll sub in the 5 and the 6 for the x and the y. So 6 equals negative 2/5. Instead of x, we're subbing in 5. I'm going to write that as 5 over 1. And then plus 8 are 5. So we'll cross cancel here. So we end up with 6 equals negative 2 plus 8. 6 equals negative 2 plus 8 is 6. So that checks out. Okay. So our solution is 5, 6. Number 2. Four x minus 4y equals 24. And 2x plus 5y equals 20. So neither one of these equations is in slope-intercept form, so we're going to go ahead and put them both into slope-intercept form. So 4x minus 4y equals 24. Subtract 4x from each side, so negative 4y equals negative 4x plus 24. Divide each term by negative 4. Negative 4 divided by negative 4 is positive 1, so we get 1y equals negative 4 divided by negative 4 is positive 1, so x. Positive 24 divided by negative 4 is minus 6. So this equation can be rewritten as y equals x minus 6. Okay, and then let's take a look at our second equation, 2x plus 5y equals 20. Subtract 2x from each side. 5y equals negative 2x plus 20. divide each term by 5 to get y equals negative 2/5 x plus 4. Okay, so now this equation is in slope-intercept form as well. And let's go ahead and graph those two equations and find our point of intersection, and then we'll do a check step. So y equals x minus 6. We'll have a y-intercept at negative 6. And our slope is positive 1 because our coefficient of the x variable is our slope. So that's just an understood 1. So I'll just up 6, right 6. Okay. So here is y equals x minus 6. And then we need to graph y equals negative 2/5 x plus 4. So here's our y-intercept at 4, up 2, right 5. Down to right 5. Okay, and here's the line y equals negative 2/5 x plus 4. Oh, negative slope, and I graphed a positive slope, so I'm going to go ahead and fix that. Sorry about that. And we would have caught that in our check step, but I see it in the graph there. So down to right 5. And this won't have it looks like we'll have to approximate here. So up to left 5. Okay, so that is not quite going through an exact point. Let's see. It's pretty close though. Okay, so if I take a look at that equation I have, or that point of intersection, I would say that's at 7.1 and then probably 1.1. So right 7.1 and then up 1.1. And that's an approximation, again, because it's not going through an exact, it's just a little above and a little to the right. So approximately equal to 7.1, 1.1. Okay, and then let's take a look at number 3. Negative 6x minus 8y equals 24, and negative 3x minus 4y equals 16. So neither of those equations is in slope-intercept form. Let's go ahead and rewrite them. Negative 6x minus 8y equals 24. We will add 6x to each side. That gives us negative 8y equals 6x plus 24. Okay, and then we divide each term by 8 to get y equals, and 6 and 8 have a GCF of 2, so 3/4, so negative 3/4 x minus 3. And then our second equation, negative 3x minus 4y equals 16. We will add 3x to each side. That gives us negative 4y equals 3x plus 16. Divide each term by negative 4. So we get y equals negative 3/4 x minus 4. And let's go ahead and graph each of those lines. And I didn't do the check step on this one, I'm sorry. So you can plug in your x and y values to check those for accuracy on your real test or quiz. And then let's take a look at these. We see that we have the same slopes, negative 3/4 x, or negative 3/4, and then different y-intercepts. So when we graph those, they're going to have the same slope, so they'll be parallel lines because they have different y-intercepts. So there will be no solution because parallel lines never intersect, but let's graph that because it's part of our task as well. So y equals negative 3/4 x minus 3. Oh, it's negative slope, so down 3, right 4. I'm just going to check that one. And I can go up 3, right 4. Excuse me, up 3, left 4. All right, and then our next equation was y equals negative 3/4 x minus 4. So really close together. Okay, here down 3, right 4. And then additional points to graph. And then we can see that they are parallel lines with different, which means they have the same slope, different y-intercept. And so the two lines will never intersect. They have no solution. Okay, so that's just mini quiz, solving systems of linear equations by graphing.